Welcome back. I hope everybody's break was wonderful. Hello. They're all sitting so far away. So far away. Why is this still not working?
Oh my god.
What are you doing?
Oh,
Please pull out your notes on the last unit we were doing. I'm gonna have you writing out some equations. Do I have? No, I do have stuff up. Okay. Are we currently live from downtown today?
I don't know where we are.
Are we? Yeah, we appear to be live. Nice. Okay. And we won't be starting I. I think we're doing H. I is the last one, and then we have our last test. Not the last test. The last test that's a major multi.
Wait, is I like the last unit?
We do?
No.
No.
Nothing happened. Put your brain to sleep. Nothing. I said nothing.
I is the last unit? No.
What? You haven't even seen the notes.
I know, but I don't have any of the... Are we on H?
Yeah. Right. H. You're supposed to be I. If you don't have H, I'll try and find them while you're doing stuff. All will be well, and I'll make sure things will be well. Pardon? My computer needs a restart. This is painfully slow.
Is it good? That's good.
No. Look at that. Oh, there you go. I believe we already did this one. Do you have this on your page? Or we did ones like these. You're right there. You're there. Okay, excellent. Let's you did them on the board. I'm gonna have you do it again. Because just a little warm up on Dojo Safe.
Snoop, I thought we were gonna switch up the method first. Gang partner.
Were we? How was I gonna
What's
switch
wrong
it
with this
up?
method?
That was a term ago. I have no idea what you're talking about. What were we gonna do?
I don't know. I thought you said there was a different way.
I
I think I always put with the same 2 or 3 people.
Oh, right. Remind me of that because I can make an Excel spreadsheet that is the same thing. Are you with the same person this time?
Oh, no, I'm not.
Oh, there you go. Okay. Grab your partner. Find a spot on the board. If there's a picture there, very carefully, put it somewhere else.
My partner's not here.
Oh. Is anybody else's partner's not here? There. You two join. Over there. Find the people. Declan's not here. I can do 10 this way. And Sienna's not here. Okay, people? Good? Good. Okay. Iron 2 sulfate reacts with ammonium sulfide to produce a precipitate and a soluble salt. Using your solubility table, predict the products, their phase, and write out the formula, complete ionic, and meta-ionic equation. And while you're doing that, I'll do 10. You'll need a solubility table. Now, who's away? Sienna's away. And Declan's away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 we shall have 14 people left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm still missing one person. Does anybody else have a partner? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I just can't count. Don't forget to consider the charges when making your compounds. Make sure they crisscross correctly. And for any polyatomics, don't remove their subscripts. What's ammonium sulfide? What's ammonium? You have a tape NH4. Why do you have NH4?
Oh, what?
It's crazy. Yeah. You have done one thing correct and one thing wrong. Yeah. I would like you to write out NH4 with its charge separately right now. Just write it. No. That's N4.
No, this would be NH4.
And what's its charge? What's its charge? What's its charge? No. What's its charge? Let's look it up. What's its charge?
Find it. No, it's
Just plus. Oh my god.
Oh, then 2.
Oh, it's 4.
No, it's 2.
Wait,
No. What is the formula for NH4?
NH4.
Sorry. What is?
Oh, you're right, yeah.
Oh, thank God.
Thank you.
You're welcome.
Okay, so then the salt.
Now other people can.
What's
I
the
want
salt?
everyone to take a look at the formula for ammonium and double check what you have. Ammonium. You guys are good.
So,
A reminder, don't use brackets when the number outside the brackets is 1.
I think this is going to dissolve everything with this. That's a form of everything here, so it's going to be the soluble salt, right? It's going to be the soluble salt. It's not going to be this. If it contains everything, it's going to be the soluble salt. So yeah, no, she's right, because that was the precipitate, or this precipitate, this was the
I never had strep. You were wrong.
NH was the one.
I think that was worse. No, good. Is there like a sickness we do? So it'd be NH4.
If I can get everybody's attention one more time.
It's called a cold.
Just a writing formula thing. If you have a formula, you know you have 2 species, which one comes first? Say randomly ammonium and sulfate. Which one comes first? Ammonium. Why? Because what? No, there's a reason. Why does it come first? Positive. Positive ones first. Metals first or positive ones first? Metals are first because positives are first. Always positives first. Even if it's covalent, the most electropositive is always first. Because people just like positive people more than others. So if you have it the other way around, please fix it before my eyes cross.
Oh, but that doesn't mean that all. Oh, we gotta balance this. We gotta balance it.
That one I know how to do, I think.
B, fix.
You were, no.
You have sulfate ammonium.
These two?
Which one is written with the positive one second? First.
Or SO4. Switch.
The,
There you go.
soluble
That
is
is-
aqueous. Is it right? Yeah, I think so.
You erased the wrong one. That one was good.
I remember writing H. I don't remember SO4.
No, the actual compound.
What's SO4's?
What's wrong with SO4 bracket NH4 to 2?
You don't.
Yeah, you do.
What's the charge on SO4?
Oh, that like applies to, no, it's not SO4.
Yeah, the ammonium must be in front because it's positive. That's just the one writing formula.
Oh, okay, it bounced.
And I've noticed this is happening more often. I'm blaming Meta.
No, this is just writing all out again and then
Is that right?
What?
this part for the,
Yeah, but it wouldn't have brackets in it.
okay, so
You balance it, take the 2 outside, put it in front.
right,
Nice.
Yeah, did we balance our coaches?
yeah. This is just
Don't forget your state symbols.
What's the charge on this? And then plus as oh my god, this is you fell over down.
Where point to yours.
It's to see if it's balanced.
Do you is your on the right hand side? Does that say 2NH2? Yeah.
2 NH4
4 plus. Okay, but I just use better. And SO4 minus 1.
yeah.
Okay. There's a mistake in that.
Oh.
But you're close.
Oh, SO4 this is the soluble salt.
Da-da-da-da-da-da.
Is that it?
You are done, I think. Yeah. That was the only thing. Yeah, just turn. You guys good? Did you put state symbols in there? Yep. Good. Well done.
Thank you.
Good job. Good job for first day back. Good job. Appreciate it. Yeah, correctly. Put state symbols in that one, to make it obvious. But yes. Ooh, so correct. Not because you don't separate the solids. They actually stays together. Other than that, good. Oh, got it. Balancing? Yep. Oh, balancing on the left.
It's not already balanced?
This is my favorite part. The just-
Oh, put the 2 in front of it.
Yeah. Yeah.
No, it's there. It's there.
No, it's not.
There's 2 there.
Where?
In front of the other
Yeah,
one.
there. What about this way?
Oh.
There you go.
Ours were brick market. All this stuff. Sushi hour. And then
Are you?
I went to Olivier Shop from Howard.
What is it? I don't know, I asked them.
Data table? Should be lots up there.
No package?
Oh, no package? I will check. You can just, look through that just to see if you can find one.
I'm just going to steam here. I'm trying to learn 180.
Do you want to be library person? No, I have no pet.
It's hard.
No, it's just like really funny. 90 minutes of not making it sound bad. It wasn't sound nice. Next time.
Found the line.
Okay, how did you know that iron sulfide was the precipitate?
Because they don't dissolve.
They don't dissolve. How did you know that ammonium sulfate could not be the precipitate?
Because they dissolve.
Which one dissolves?
Ammonium.
Ammonium. Ammonium is soluble with everything. If you remember nitrate, ammonium, and the alkali ions are soluble with everything, that like eliminates 90% of all the questions you get in terms of trying to figure out which one's which. So it's helpful to know your alkali ions. You already have this down. Iron exists in both reactants and products. Note-wise, yay or nay?
Yes. But what was that?
No.
No. Write down spectator ion. We must have done it. Put away your phones. Where's the whole spot up there? So, of these, what are the spectator ions? What do we got? What are spectators? Fe? Is not a spectator.
Wait, I thought it was
Sulfate.
Sulfate exists on both sides, aqueous. So it did not take part in the reaction to make the solid. So their phases are different, so something happened. These are the same, they're just spectators.
And ammonium.
And ammonium. So ammonium is a spectator. So these are all spectators. And I will belabor the point by labeling them all. Infinite. Called spectators because they don't actually take part, just like if you go and you watch a game, the spectators walk in, nothing happens to them, and they walk out, where the people playing the game come out with bumps, bruises, they actually did something. So iron and sulfide, iron 2, came together, formed iron solid, so they actually did something, everything else just stayed the same. But you need the spectator ions because you have to go to make iron sulfide. Iron has to have a partner, so it had iron sulfate. Ammonium needs to have a partner to bring it there, so it had, sulfide needs a partner, so we had it with ammonium. And then we can bring them to there. We can't get ions off the shelf. They are either in solution, and to get them in solution, you have to go get some sort of solid and dissolve it in. So you'll have spectators at the beginning, and then this is just to focus on what's actually relevant. We did these as examples, I believe, but we did them in class. Predict qualitative changes on the solubility equilibrium upon the addition of a common ion. This is the common ion effect. So, let's just go back, since it's been a whole term. We predicted solubility equilibrium. We talked about low solubility and soluble. We practiced making sure that we can do predictions of charge, because charge becomes really important. We defined what's soluble, insoluble. R, concentrated, super concentrated. We did a little exercise with homeopathic medicine. We predicted with a solubility chart, which we just did again. I believe we actually did this on the board last day, and then we just practice it. We practiced an example here of coming up with a procedure. Did we do that one last day? We did that one. Did you do that one?
We did none of this.
We did this one.
We should just redo it.
It wouldn't be a bad one. It's a good one. You have a beaker. Where are we good? Groups of 2. Find new people. Go to the board. Evan, did you with the people that you always get?
I don't remember what I was at. I feel like there's not a lot of berries.
It's not very scrambled? Oh, don't take your notes with you.
Oh.
Put your notes back in your desk.
Damn it.
Because the notes tell you how. Take your data booklet with you. Yeah, data booklet. I mean, you want to walk back to your notes to get a hint, but ideally you need to be able to do this. You should have a functional understanding so you can do this without the solution in front of you. The solution is already given to you there. That you're to do it on the board. And you may come up with different numbers. We'll cross things out. Everybody got the part? Okay. So the question is, you have a beaker, and inside that beaker of water, floating, aqueous, is copper, magnesium, and strontium. You want to separate them all out individually from the water. So you want to take out one of them, then the other, and then the last one. Okay? So using only your data table, what are you going to take apart?
Wait, Mr. Phil, do we have to use the table? Can we just like write out the steps?
You can write it on steps. The table is, Marcus, I find the table helpful just for me to record like what precipitates with what. And so it's just useful to organize, but then you write out the steps.
No. Yeah. Or you can use one of them.
I do, but I don't.
That means if it comes to solid, oh, we can use.
I don't know if that's correct or not, but I do know you don't have the right species. You've written copper plus 1. And copper plus 1 and copper plus 2 are different things. Okay. Same thing. Copper plus 1 and copper plus 2 are different things.
No,
Because they'll precipitate with different things. And so you just want to be careful that you have the right cat on it. Pardon? Sorry?
If you look at the first step, it says that Cu2 is soluble, but it's not.
Which anion are you using? Like, which part of the table are you looking at? It's on the table in all sorts of places.
Oh, this. We were doing tackle back right on.
Oh, I see. Where did you tackle?
When you have what works with what, write out your procedure. What do you do after you precipitate? You're just going to precipitate one after the other, and then you write that in. filtered up, set aside.
That's true, they never said you can't leave it in love.
You don't have your phone on, do you? Haven't?
No, I'm not.
I have to talk to your husband.
Because now you're living in
Take it away for a day.
For anything else, like
It's just all the my AirPods.
Oh, do you just filter it up once?
it's soluble.
So you just got a bunch of powder
So when we have to
that's
like
all the mixed together. Filter set aside, filter set aside, one or.
leave.
Oh, leave.
Oh.
Oh, you're just gonna leave it in the beaker. You do need to filter it. Because the solution could have other stuff, you wanna get it out of the solution. But I do take your point. As lazy. Lazy, I understand your point. Alright, you're here?
We need to do one that'll.
Yeah.
I tried to watch something that I could not feel it.
Oh, this is the sound not working? Sorry. Yeah, I don't have the best microphone.
Okay, those are ones that work.
Okay. Maybe it's a sad day. We have somebody who can talk. How much do this? You're not in sport now, and you decided to vote the rest of the term just for chemistry.
I will only miss 5 days from hockey and then like 6 days from
Wait, what?
You're going better as your therapist. So,
No, wait, no, January, this month.
this month?
No, this month, maybe max then.
There's only like 3 weeks left of the month.
Yeah, that's
Yeah.
I thought this was your What? Yeah, this is hockey. You're in hockey now. What were you in last term? Volleyball. And then you switch sports to another competitor.
I said 4 2.
Not saying that? Have you, now, have you considered other competitors? Because I have one in mind. No. Although, not bad.
No, I mean this.
Yes, it is.
Mr. Duba.
Oh, sodium and copper will not precipitate each other.
You guys.
Yeah, if you add, because copper and sodium are both metals, they're both positive. So you need the negative part of the and phosphate's almost full sodium in everything, so be really careful about it. Phosphate, like you let something that precipitates. Are we doing that? So for your phone, the guy here, you said, chlorine. So bad. No, because then it'll precipitate all of them at once. You want to separate. Do you see? So you go chloride, and then once you filter it out, set it aside. Now that's out, and then you can use the sulfate, filter out, set aside, and now there's only one left. You can use the phosphate.
So then would it be CU?
Well, it is. You're precipitating out the copper, so it's copper. And it's plus 2 minus 1. Plus 2 minus 1.
I know I should be
See,
just last night actually.
because they usually lender. Okay, I'll let you work on that.
Mr. Duba, can you check?
Mine is valid. Mine is like, or no, yours is way better. Yours is
Sulfide only does copper. Okay, you've done the same thing I think you did in the last one. When you write compounds, which one comes first? For your number 1, you have sulfide 12.
No,
what, Glenn? CUS.
Oh, yeah.
I need to let you know what you're doing. No,
Love corn.
And one S2.
And then.
What's the charge in copper?
oh, no, it's actually
Yeah, CUS. Because,
I have not used it.
or cuss. Yep. You have to be soluble, so sodium is a good choice. Yeah.
You can do it
Yeah. Any of the alcohol. Your magnesium is missing brackets. Magnesium is not there. And then, where do you think?
No, we do that like so often. We've done skating.
And like this group here, you need to, once you do it, you need to filter it. So
We
you
went to
powder.
powder.
If you just add it, then you'll just get a powder with all three. Then just get I think so. Now I'm gonna show you the table. You're gonna put yours in and just make sure that they do work. I'll do an example.
Do we have to there
No, you can just fill it out. Right, I'm gonna check it out. You have your table, and just as all things that I'm gonna teach you. Allows me to give you.
Peter,
Okay, have a seat.
I think it's just
They just really like tables.
hey, stop.
Now, there's more than one right answer for this. I would like you to take yours, double check it in the table in your notes. So what you do for each one of these, gentlemen, the reason that I use a table to start off with, this is not the answer, but it's a way to check that you have the right order. So I'm going to use this one right here as my example. If we put in, okay, I'm going to try chloride, which means I'm going to add sodium chloride because I need something to add it with, and sodium is an alkali metal, soluble with everything. You get a precipitate with copper plus 2.
But doesn't it only precipitate copper plus?
Oh, I am just believing the board. Let me check. No, I haven't got it. Here we go. Oh, perfect. That does another that does our other example. Where's it here? No, here. So, if I do chloride precipitates copper plus 1. Where would copper plus 2 be? All others. So, unfortunately, if you used chloride, it is not going to work.
Or any of the ones in there, right?
Chloride does not precipitate magnesium, copper plus 2, or strontium plus 2. So chloride is not going to work for this at all. You need something that's going to precipitate one of those. They're not in there. What does anybody know? What have one that did work that only precipitated 1? Pardon? FES. Iron isn't there. And we have S minus precipitates copper plus 2, so that would be down there. Yeah, so that'd work. Does it precipitate magnesium? No, so that's good. And does it precipitate strontium? No, that's good. So you do have one. And you used Fe because Fe would be down here in all others, which is not a good way to add it. Because what would happen if you added iron sulfide? It's a solid, you can't dissolve it. So it itself doesn't come out of solution. So what would you want to, if you're going to add S, what partner should you give it? What partner would make it soluble?
Barium sulfide.
Barium sulfide would work. I'd accept that. Barium sulfide,
Else?
Don't add more of these, but you could use ammonium, hydrogen. What's a good alkali ion? Anybody's favorite alkali ion? Everybody's worried about. Pardon?
You have a favorite?
Yeah, of course I do. Everybody does.
What's your?
Sodium. Because sodium chloride is delicious. Put salt on everything. So good. Na plus, K plus, lithium. I tend to pick sodium because I know sodium is common, cheap, and if you want to find a compound that's soluble in something, you can usually buy it as a sodium version. And so it's just practically the one you're more likely. But you can use any one of these. So to go back to it. Not that one. Let's not use that one. We will use sodium sulfide, which is S minus 2, and that precipitates this one, and this is soluble, and this is soluble, right? The table is, again, if you use the table and you mess up, then you can just keep going until you find ones that work. What's another one that precipitates only one of them? Anybody discover them? Pardon? SO4. So again, I would use Na2SO4. Be consistent. If you know it's going to be soluble, just use the same one every time. If it's soluble to everything, and that way you're not adding new things to the system, which is important if you're doing an experiment. And let's double check. Sulfate. What does sulfate precipitate? So we got sulfate. And it has low solubility with barium, and it doesn't matter. Silver, it is soluble with copper plus 2, so that's fine. Magnesium plus 2 would be up here. And strontium plus 2 is here. Low solubility, perfect. It only precipitates one of them. So, we have a precipitate with strontium sulfate. This is soluble. This is soluble. If you're going to do this as a procedure, does it matter which one you do first? No. Because it's only soluble to one. However, if you found one that precipitated both copper and strontium, then all you do is use it second. Get rid of all of one of them, and then the other one wouldn't matter. How we precipitate the last one, the only thing we haven't gotten is magnesium. What do we use? NaOH. So NaOH. Let's double check it. OH. Come on. Where's OH hydroxide? It is soluble with strontium. Low solubility is copper plus 2. And what's our other one? Magnesium plus 2. So if we go back. Whoop. So we have a precipitate here. We have a precipitate here. And this one's soluble. This is not the procedure. This is just a way to figure out what the procedure is. So if you do this at the beginning of your question, it helps because I can then look. If you made a mistake in just picking yours out, then I can say, oh, they thought this was soluble with this, but it's really not. But, you know, that, geez, what is, I do not want the feedback hub. So I gave hints as I go around. How do we write this up as a procedure? First step. I see 16 eyes looking at me very patiently. So I will just select Henry. Start us off.
I guess adding Na2S to the solution.
Yep. And at that point, which one are you going to precipitate?
The Cu2.
Yes. So we'll precipitate CUS, filter, and set. Aside. Good. That's step one. Second step, Matt.
You do the same thing, but you're adding Na2SO4, and instead you're precipitating the SR SO4.
Say it again. The compound we're precipitating is.
I think is it SR2SO4? I don't know.
What's the charge on strontium?
I don't know my data book with me. I'm not sure.
No, it's right on the board.
Oh,
What's the charge?
+2.
Plus 2. Oop. And what's the charge on SO4?
I have no idea. 2.
Minus 2. So if we put them together,
Oh yeah, so it is just SR.
it's just SR, SO4. Excellent. Filter, set aside. And so on and so forth. Come on. There we go. And what's the last one we're adding? Anyways. So right now, if your example, because you say chloride first, there was a few that had chloride or a couple, fix it. Write in a working method for yours that you picked out for this particular type of problem. So you have your particular example using this as a model. Give you a few minutes just to make sure you have that down there. Because the table itself is not the solution, you need to explain how you do it. We might actually do something similar in the lab. Okay, show me yours. I just said, where does yours? Because when I say I want to see a working model, you've got some room somewhere to write it out. What are you
I'm
doing?
doing breathing exercise.
What kind of breathing exercise?
Just breathing.
Do you mean box breathing?
I don't know what it was. I was just following what he was telling me. Yeah.
Explain.
It's just a relaxation session.
So like I stressed you out,
Yeah.
and your watch told you, and then it gave you an exercise. That's actually kind of cool. I love that. Yeah. Because all the alkaline metals are soluble everywhere.
So why was he doing
I'm going to grab my keys 1 second, because did I teach anybody here? No. And you're not the only one with this question. I've said it, but I don't think you really realize it. So we want to add sulfate. So practically, if you have a solution and you want to add sulfate, we have to add sulfate. So everybody stand up. Like stand, like literally stand. Marcus, stand. Evan? 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 Marcus! Follow me.
I had the same question.
Did you get your makeup? Wait, I'll just literally text you.
Oh, cool. It's an emoji. If you go here and then like you press that, what are you guys doing?
Got it.
What the fuck is this? It's AI emoji. Oh, you might have to go, if you go into settings, you have to like set it up.
Oh, I got it. Apple Intelligence.
Okay, wait,
Yeah.
send me one. Okay, well.
I don't know how, but he does, and so I'm really good at it.
No, I'm saying yours doesn't look bad. What shampoo do you use?
Okay, I would like you to, I'm only going to give you a couple more minutes because I keep getting a feeling that people are not necessarily wanting to read a lot. Get your procedure done. Yes?
Never mind.
Are you sure?
Yes.
Okay. Give you 1 second. Where is? If you wrote notes and you don't have them anymore, somebody's is right here. If you recognize where I'm writing. anybody who doesn't have the sheets that needed one? Did you? I found more. Oh, hold it, these are G, not H.
It's okay, I can just
Pardon?
I can just print them off.
You can just print them off, I believe. I will continue to look, because I think someone else also has them.
Oh, I got it on the iPad.
Noosh, when's our next big test?
Once we're done, then there's, this is all the solubility unit. We have one more section of this unit, I. And once we're done that,
It's like
then it's time for the next test.
in like 2 weeks?
I don't want to put a definite date on it, but like early next week probably.
Early next week?
No, I just said that to see if you're paying attention.
Wait, so it's GHI?
Like early 2 weeks from now?
Yeah, sure.
He has no idea.
And this is the last cumulative test in this section. So the next test, you will have, this test will be on reaction kinetics, equilibrium, and solubility.
So A, B, C, D.
A, B, C, D, E, F, G, H, I.
That's like cool.
Wait, so there's no, like, J, I mean, what is it?
A, B, C?
No. Like, there's no, like, smaller test and then bigger test?
No. Well, then one more big test. And then the test after that is just going to be JKL.
But there's no
Oh, so it's like
So,
grouped together.
so you'll probably have like a quiz next week,
Oh, okay.
as we normally do on like a part of the material. But,
But there's no like unit. Like,
there, yeah.
I don't remember.
Is that like weighted the same?
Wait, is it a cross grade?
It's a cross grade? Is it not?
What?
It's a cross grade?
I used the word cross grade last time, just to like tell you, like, we're all doing, it's just a cumulative test. The cross grade was just a cumulative test.
Can we get a review block?
So if this one's not like
I want to do a review block, yeah.
if this one's not like a cross grade, you're gonna put like a load of multiple.
It will, oh, this is not one I'm necessarily going to share with Mr. Snow and Ms. Carroll, so it'll be more like the other tests. Because we sort of merged kind of what we do. I am going to be looking more carefully though at what they do, make sure that I'm not penalizing you if I'm doing things that result in your marks getting lower or something. Just make sure that we're all on the same page. Okay, stop. New stuff. Turn to this page. H5. Go. We have like, what, 5 minutes left? We're going to use those 5 minutes. Predict the qualitative changes on the solubility equilibrium on the addition of a common ion. This is known as the common ion effect. This is one of those magic words that when you want to explain what something's doing in a really short way for 1 mark, you go, it's the common ion effect. It actually confused me for a long time as a student because it's just equilibrium. This is just Le Chatelier's principle. It's not anything really different. But I'll show why. The common ion effect. Common ion effect is if we want to make, I'll fill that in a moment. Let's say we want to make more solid. We want more solid to appear. What could I add to shift the equilibrium to make more solid? Or another way of phrasing it, how can I lower the solubility of as to, so that less of it dissolves? How could we shift the equilibrium to the left, to the left, to the left?
Can we, like, decrease the temperature?
We don't have any heat information. Really good idea, but no, we're not going to do that. You can, but we're not going to.
Could
Yeah.
you
Add more?
yeah.
Of what?
AZ2?
Right. No. If you add more AZ2, you haven't. First of all, it doesn't shift. If you increase the amount of this, which way does it shift? Yes.
Oh, I have the answer. If you add more, it's going to go down.
If you add more, it's going to go that way. Hands up if you believe if you add more of this, it's going to go that way.
Yeah.
Put down your hands. How many of you now believe it goes the other way? Also doesn't go the other way. What is the KSP as an equation for this? This is just the KQ. If you wrote the KQ for this equation, what would you write? I'm not going off on the side thing, but write what is it? What concentration what? Yes? B, Z. Squared, because it has that in front. Great, yeah. Over nothing. Why over nothing? It's over 1, but why are you not putting that on the bottom? It's a solid. Does it affect the equilibrium? No. So it doesn't matter how many of those you add. It doesn't change anything. It's not even in the equilibrium expression. So that's the easy way to show you. That's why it doesn't affect it. The other way, remember that what affects the equilibrium is a change in concentration. What is the concentration of a solid? No, they all have a concentration. It's just a different thing. But the concentration of lead is different than the concentration of gold, but we call it by a different name. Density. Do we change the density by adding more? No. It's like, which weighs more, a ton of feathers or a ton of lead? They're the same because they both weigh a ton, but we have this instinctive thing to say lead because we know it's heavy. But if you have a ton of both, they're the same. They just have different densities. We'd expect a much bigger amount of feathers than the amount of lead. So adding more of this doesn't do anything because it's a solid. So it was a bit of a trick. So adding something was a good instinct. It's just not this one. And also, if this was aqueous, for all of you, I said put down your hands and I acted kind of angry. Yeah, if it was aqueous, it would have done it that way. So your instinct wasn't completely off. It just was a solid. If you take it away, do you change the density? No. And if you take all of it away, it's no longer in equilibrium. It's not saturated. What could we add more to make it go this way? So add more A, but can we, again, I'm going to march you in there and say pick it off the shelf. We can't just add A plus 2. It's got to have a partner. What partner are you going to pick? What negative ion is soluble with everything? So I thought somebody said no. Did you? What? Oh, yes. Na plus 1. They're both positive. So we can't use a positive. We need a negative. Where's your K? What is it? Negative. What? OH? OH is not soluble with everything.
It's NaO3.
It's what?
NaO3.
And nitrate, yeah. So instead of adding more A plus 2, we would say we'd add more A NO3 2. Whatever A is, add more nitrate. That will, if I star this with red, that will increase the amount of that and shift the equilibrium over there. So if I have a solution of A nitrate, then not as much AZ will dissolve because of the common ion effect. Because they share an ion in common, you can't dissolve the same amount. So if I'm trying to dissolve gold chloride, and I'm using seawater instead of tap water, why won't that work as well? Pardon? The salt, what is salt? Formula of salt. NaCl. They both have chloride. So they share an ion in common, it won't dissolve. If you have a choice, use tap water, but what would be better than tap water? Pardon? Distilled water. By the way, do you know why you should never drink distilled water? Does anybody here buy distilled water and drink it? Because it's the purest form of water. It is considered medically dangerous to drink distilled water, especially if you drink it exclusively, because regular water does have stuff dissolved in it, and that's an important source of your minerals. If you drink distilled water, you can get the opposite effect. Your minerals will actually come out of your blood to diffuse into the distilled water, and you actually lose minerals over time, and you can weaken your bones. What else can we add? Someone, did you say that? What else can we add? Yes?
Could you do Z with like a positive?
Yeah. So pick a positive. What positive one do you want to use?
Na.
Na, perfect. Add more NaZ. And here we can see with this one, we have common ion, and here we have common ion. And it shifts the equilibrium. That way you can't dissolve quite as much. Notice the common ion effect. You're just looking for similarities in ions, because if you have a similar ion, it's going to shift the equilibrium, so you just can't dissolve as much as you otherwise would do. Questions? Is it making kind of sense? It's like the second day back, and I don't know where your brain fog is. Mine is still somewhere in Christmas, so. Okay, one more skill testing question. What could you add so more would dissolve? How could you shift it that way? To the right, to the right. Shift it that way. That way. Shift it that way. Watch me walking in the direction. I want you to shift it. Well, you could, but we've already had a big, long discussion. Can you just add more of this to shift it that way?
But like the same thing that you did with the A and the Z, like finding just add one.
If I add a common ion, it's going to shift to the left. Yeah?
Can you like dissolve it or like melt it?
Yeah,
We're not allowed to raise the temperature.
add water.
Yeah?
Can you add something that'll make it soluble?
Nope. Well, yeah, you can add something. That's what I'm asking. What would you add?
We don't know what it is.
We're adding.
Pardon?
But we don't know what AZ is.
Yeah, it's AZ.
Could you just add this?
Pardon?
Could you just add like water?
Then you're just changing the volume and you're changing all the concentration. It's not this. You don't change the solubility. You just added more water for it to be soluble in it. Right? When we increase these, it shifted left. What can we do to make it shift right? Decrease them. Add something that precipitates them. So if you found something that precipitated A and dropped A, it would shift to the left. I'm sorry, right. I said left and pointed right. Does that make sense?
But I thought you said the density. Oh, you just find something.
You find something that precipitates A. Like these are made up. So I don't know. Maybe W minus 2 precipitates A. Add sodium W, and the W react, drops it, you dissolve more. Thank you very much. Enjoy your last class of your second day back.